Hi and welcome. In this tutorial, I'm going to discuss about how to interface an LED with AT89S52 microcontroller and how to use the delay function of MikroC compiler. So first of all, I have a new project created in compiler with the name LED interface, and I have this simulation model placed in ISIS with the SIP network connected to port 0. First, we need to know that how we can use LEDs with microcontrollers. There are actually two methods to use the LEDs. First of all, we need LED and resistance from the device categories. I will use red LED, and you can see one animated LED model is there. Double click on it. Next, I need a resistance type RES and select this device. Double click on it and cancel this window. The resistance value will depend upon the supply voltage for LED and LED type. So in one configuration, we will connect a supply source on the anode of the LED and ground to the other terminal of LED. So in this way, the current will flow from supply, then from anode to cathode of LED, and this current limiting resistance to ground, and this LED will glow. So this is one configuration to use the LED with microcontroller. In first configuration, the supply will be provided by the microcontroller pin, and when it will be high, then it will turn on the LED, and when it is low, it will turn off the LED. In second configuration, we will connect the cathode of this LED to the microcontroller pin and anode of this LED to 5-volt power supply. I will copy and paste these devices. So select the devices, right click and copy to clipboard, and right click again to paste. One LED I will connect in this configuration on port 2.0. One ground is connected in this way, and for second LED I have to change the direction. Then I am connecting it to port 3.0 pin, and this side will be a 5-volt supply. We need to change the names because we cannot use D1 here and D1 here, R1 here and R1 here again. So change it to D2 and change it to R. Now for LED1, if the pin is high, then it will turn on the LED, and for LED2, if the pin is low, then it will turn on the LED. So here in the programming side, if I write port 2 is equal to 0xFF, means all the pins high, and port 3 is equal to 0x00, means all the pins are low. Compile the program, assign the hex file, and run the simulation. Now you can see both the LEDs are glowing. Why? Because for LED1 we have pin status 1, which is connected to the anode of the LED, and that's why this LED is glowing. And the cathode of LED is connected through this current limiting resistance to the ground. And why this second LED is turned on? Because we have this 5-volt supply on the anode of this LED, and through this current limiting resistance, the port pin is providing the ground path. If I change the port status, port 2 to 00 and port 3 to FF, again if I compile it, run it, now we have port 2 pin 0 is equal to 0. So on the anode side we have 0, and on the cathode side we have 0 through this ground. That's why this LED is not turning on. Now for the second LED, we have this 5-volt supply connected to the anode, and again we have this 5-volt from the controller's pin connected to the other end of the LED. I will prefer the second arrangement, where we have to provide the ground signal from the port of microcontroller, because 8051 sink more current than source sink. Now let's try to write a program to toggle these two LEDs. The delay function is delay underscore ms. ms stands for milliseconds. For how much time we need to provide the delay in milliseconds, we will write that value inside these two parentheses. I want to provide a delay of 500 milliseconds, so I will write 500 or half a second. Then again port 2 is equal to 0x FF, then port 3 is equal to 0x00. So first we have a different status on the ports, then the delay of half second, then we have a different status on the ports, and then again a delay of half a second. So compile it and run the simulation. So it is a single time off and on operation. We have to repeat the sequence. For this we need to create a while one loop, starting off this while one and ending of this while one after the delay instruction. So we can see we have this while one loop which is containing all these instructions, and this while one will create an infinite execution loop for all these instructions. Now you can see all these two LEDs are toggling with a delay of half a second, and you can also see the status change on the port 2 and port 3. So this is how we can use the infinite loop with the help of this while one, and how we can use the delay function provided by MikroC. So in next tutorial we will further discuss about the ports and programs. Thanks for watching, and don't forget to subscribe the channel.